and we can take ADP and use to make ATP. Oh, this isn't C208. This is C. Oh, did I draw that? Yeah, I got it right here. Now I'm gonna show you, and this is important because it kind of creates a little bit of shows the driving force. What you end up doing is there's an intermediate here, and so you first get the transfer of the phosphate, and then you get the you get this. So this is going to be enol pyruvate here, enol pyruvate. So we basically now just made this like this, and then, but you know, remember, you know, keto keto enol tautomerism. Remember that from organic chemistry, where you can kind of go through. So basically, this hydrogen, you get a it's not resonance. It's actually the movement of electrons and forming new bonds. But you basically, this ends up going there. Excellent, might as well. This goes there, and that comes down there to be able to make the keto part. And so this here is our pyruvate in a much more stable form. And the reason I mention is that actually that's what drives the thermodynamics is that this rearrangement here is so highly favored that helps drive the thermodynamics. But now what we do is we create our ATP here, and now that ATP is, remember we're doing this twice, okay, so now we're finally ahead of the game in terms of overall glycolysis. Because after that last one, the phosphoglycerate kinase, we broke even, right? So now, because this happens twice per glucose, we're generating 2 ATP, and now those are the 2 ATP that we end up with, is being ahead with after glycolysis. So this is irreversible. It's also highly spontaneous. Whew! There we go, 10 reactions. Very good. All right, let's take a little break, and then what I'm going to do is we're going to talk, you know, in terms of our overall oxidation of glucose, we talked about how this is going to go to the mitochondria and then enter pyruvate dehydrogenase in the citric acid cycle. But but all that process ends up requiring oxygen. And if oxygen isn't available in the cell, you can still get some ATP just by running glycolysis. You can get this ATP here. So then the question becomes, what do you do with this pyruvate? So we'll talk about the metabolic fates of pyruvate, and then we might just introduce a little bit of gluconeogenesis before we go. All right, so let's take, what time is it? Let's just take, let's